Okay, welcome. This is AP Statistics. My name is Todd Thedell, and this is the information from section 1.3. This starts on page 48 of your textbook. In this chapter, this section, we're going to calculate the measures of center. So we look at the mean and the median. We're going to calculate and interpret measures of spread. We're going to choose the appropriate measure of center and spread in a given setting. We're going to identify outliers mathematically now. I'm going to make and interpret dot plots or box plots of quantitative data. I'm going to use appropriate graphs and numerical summaries to compare distributions of quantitative data. All right, let's go. So first off, we're going to look at the mean. This is the average you've been calculating for many, many years. It's the most common measure of center. Sometimes we just call it the average, but it's actually called the mean average. To find the mean, we're gonna we add up all of the values and we divide by the number. That's you know that very well. In statistics, we use a symbol called X bar. X bar is will be how we're calculating, and so this just means sum of observations. The subscripts here just distinguishing them from each other, and it just means we add them all up and divide by the number of them. In mathematics, the capital Greek letter sigma is short for add them all up, and therefore the formula for the mean can be written in a little bit more compact version by saying x bar equals sigma xi, x sub I, divided by n. What does the actual mean mean? Sorry for the words, but what does it mean? It sort of means the definition would be if everything was the mean, if we added up the small and the large, then we would all get to the, and divided by 2, then we would get to the center there. So think about what the mean is defined as. Let's look at the example on page 49. And this has to do with the travel times to work in North Carolina. There's a stem plot, so we know how to look at that. And so on the next page, on page 50, it takes that stem plot and it calculates the mean time for all 15 workers. So you're going to add up the numbers. So if you look at the stem plot, you'll see that we have 5 plus 10 plus 10 plus 10 plus 10 plus 12 plus 15 plus 20 plus 20 plus 5 plus 30 plus 30 plus 40 plus 40 plus 60. We add those all up. We have 15, and then divide by 15. That was 337 divided by 15. So it comes out to 22.5 minutes. If we leave out the 60, notice what happens to the mean. Now the sum is 277, and we divide it by 14 now, but it drops the mean significantly, so from 22.5 to 19.8. So one observation can mean quite a bit of change, almost 3 minutes in the average for all of them. At the bottom of page 50, it talks a little bit about what the mean actually means. So I want you to look at that so that you have a better understanding of what it entails. Next, we're going to measure the median. I know you've done this before too. So this is another common measure of center, is the median. The median describes the midpoint of the distribution. So straight up, the middle of the numbers. The numbers such that half of the observations are smaller and the other half are larger. To find the median of a distribution, we arrange all of the observation from smallest to largest. if the number of observation is odd, the median is the center observation in the ordered list. If the number of observations is even, then we're going to find the mean or the average of the middle two. You've done this before. Here's we take those randomly selected New York workers, and we're going to calculate the commuting time. So here's the data that's given. So we're going to calculate the center. So let's calculate the X bar, or the average. I'll go ahead and pause the video and calculate that. Okay, so you should add all those up. I didn't even list all of them, but when you divide by 20, you get 31.25 minutes. If you didn't get 31.25, recheck the sum of that for your numerator. Okay, so now let's go ahead and calculate the median. So we take the stem plot, and we're going to do the median. We know that there are 20 data points, so that means the middle one is the 10th one. So we can count from the top to the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because there's 20, we have to take that 0 and that 5, which represents 20 and 25, and we have to average those two. And so 20 plus 25 is 22, divided by 2 is 22.5 minutes. So it is the mean average, everything. So we remember not to count the stems, we only the leaves, because that represents 5 and 10 and 10 and 15 and 15 and so on. Okay, so notice that the mean average is 31.25 and the median is 22.5. Why is the mean so much larger? Well, it's because this data happens to be skewed. The mean is pulled towards a skewness. Notice there's an 85 in here. That's skewed. There's that one, but all these this is the main bunch right in here, but these are sort of skewed out to the right. Right meaning that if we tip this over and this was in numerical order 0 to 8, then this would be the right on the bottom. So the mean is pulled towards the skewness. The median is resistance to skewness. If we took that 85 and we made it 95, 105, 205, it's not going to change the median, right? Because we're just counting the number of data points. But it would certainly change the mean if this was 205 rather than 85 minutes. So when do we use which? There's another think about it on page 53 that helps you decide when you're going to use which one, and it really depends on the data that you're using. And it uses the idea that, you know, in Major League Baseball there are the average, the minimum salary is $480,000, and some players make $10 million. So that's definitely going to be skewed to the right. So we would rather use the median average so that we know what the middle of the thing is. Anyway, read through that. That's very interesting. And then you can even look at the check your understanding so you're sure you understand that. Okay, so now that we've talked about the center, we're going to measure the spread. So we can actually calculate the spread. Remember before we were saying, oh, it's between 10 and 20 is the main grouping. But now we're actually going to measure what that spread is. It can be misleading. A useful numerical description of a distribution requires both a measure of center and spread. So what we're going to do is we're going to calculate what's called the interquartile range, or abbreviated IQR. Interquartile range. So it's the range of the interquartiles. And here's how we're going to do it. To calculate the quartiles, we're going to think of quartiles as quarter points. Arrange the observations in increasing order and locate the median. Okay, the first quartile, abbreviated Q1, is the median of the observations located on the left. The third quartile is the median of the observations located on the right of the median. So the median itself, this median, would actually be like Q2, would be the halfway or the second quarter. The interquartile range is just defined as the difference between Q3 and Q1. Of course, we'll do an example so you can see how that works. The IQR, graphically speaking, the IQR represents the middle half since there is a quarter above and below it. So this would be half, and the green would be half. So this was what we call the middle half. So this would be the median, this would be the Q1, this would be the Q2. If this represented numbers from, in order from least to greatest. So maybe that helps for you to see what that is. So let's go ahead and do an example. We're going to take those New York commuters, and we're going to take their data. The very first thing we do is we take that data and we have to put it in order. Okay, well, I've done this for you, so you don't have to do it, but when you get to doing your own IQRs, you will have to put those in order. Sometimes that is challenging. Make sure as you go through, you find the smallest and then check them off as you go to make sure you have all of them. Okay, so the first thing we're going to do is we're going to locate the median. Because there are 20, we're going to take that middle, remember that middle 20 and 25? We already calculated it to be 22.5. We are then going to find the middle of the left side. So there are 10 data points there. So that means 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. Both of them are 15, so Q1 is 15. We're supposed to average those two, but 15, average of 15 and 15 is 15. Up here at Q3, we go 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, and we have between 40 and 45, so we average those, and it would be 42.5. So remember, this is Q1, and that's Q3, and remember the halfway is Q2, or 2/4. Am I confused you yet? Okay, so the IQR is defined as Q3 minus Q1. So we simply take the 42.5 and subtract 15. And then we end up with 27.5 minutes. What does this mean? What does 27.5 minutes mean? What is the meaning of it? That means that's the middle half. The range of the middle half of travel times for the New Yorkers in the sample is 27.5. So that the middle of them the range is 27.5. That doesn't mean any one person was 27.5 minutes. It's the range of the middle of them. It's going to become useful in just a moment. Okay, so you should be able to find and interpret the interquartile range. Okay, so we can use the IQR in order to calculate the outliers. In addition to serving as a measure of spread, so we can just see what the spread is in the middle, the interquartile range is also used as a rule of thumb for identifying outliers. Okay, this is going to be more math than you've had so far. We use what's called the 1.5 times the IQR rule for outliers. Now that is a very long name, the 1.5 times IQR. And so we maybe just call it the 1.5 rule if we want. So we're going to call a data point, an observation or a data point, an outlier, if it falls more than 1.5 times the interquartile range, above the third quarter or below the first quartile. Okay, so first off, you can sort of see the process we have to go through. First off, we take the data and we have to find the IQR. We're then going to multiply that by 1.5. We're then going to add it to the third quartile and subtract it from the second quartile, and then check to see if we have any data that is more than those numbers. So here we go. In the New York travel time data, we found the quartile 1 was 15 and the quartile 3 was 42.5. So the IQR was 27.5. All right, we already did that. Now we multiply that by 1.5. So we get 41.25. Don't stop there, because we're going to look at it above or below the third and the first quartile respectively. So the first thing we do is we take quartile 1, right, in this case 15, and we're going to subtract that 41.25 that we just found, and that gives us negative 26.25. Then we're going to add the 41.25 to the Q3, which we found that to be 42.5. That gives us 83.75. Okay, so what that means is any travel time shorter than negative 26.25, which is a bit ridiculous because you can't have negative time, or longer than 83.75 minutes is considered an outlier. Let's take a look at our data. So here is our stem plot of our data. So now we look to see, well, there aren't any negatives, so there aren't any outliers to the left. Remember, this is left. But we do have this 85 minute, which is larger than 83.75. So therefore, drum roll, 85 would be considered an outlier. Now, when we first looked at this, we looked at the spread, and we said, well, there might be, right? There's got to have a unimodal data here, skewed to the right, and this might be an outlier. We weren't sure, but now we have a mathematical way in order to calculate outliers. Very powerful. Don't forget that process for doing it. So yeah, it is a little bit confusing. Okay. From there, we're just going to look at what's called the 5-number summary. The minimum, the maximum alone tells us little about the distribution as a whole. Likewise, the median and the quartiles tell us little about the tails of the distribution. To get a quick summary of the center and spread, we combine all 5 numbers. It's called the 5-number summary of a distribution. And it consists of the minimum, the first quartile, the median, the third quartile, and the maximum. So they're not difficult to find. Remember, the median is the middle number. Quartile 1 is the middle of the left group. Quartile 3 is the middle of the right group. And then, of course, the minimum and the maximum will show up on the left and the right, respectively. Okay, so what we're going to do with that is we're going to take that information and we're going to make something graphical with it. And it is called a box and whisker plot. The 5-number summary divides the distribution roughly into quarters. This leads to a new way to display it called box plot. A central box is drawn from the first quartile to the third. A line in the box indicates the median. The lines called whiskers extend out of the box to the largest and smallest, and that are not outliers. And that's kind of key there. We don't include the outliers. And outliers are marked with a special symbol such as an asterisk. All right, so let's take a look at the New Yorkers. We first put the data in order. We find the median, the quartiles, and the minimum and the maximum. Okay, so now we're going to build this box plot. Maybe you remember this from earlier math. All right, we're going to put the first quartile, the left side of the box. The right side of the box is the third quartile, and then there's a line in the middle. Notice that they are strategically placed so that 15 is right above the number line 15. 22.5 is there, and 42.5 is there. We're then going to put the minimum out here. So the whisker out here goes out to the minimum. So there's 5. And then the maximum is 85. However, we figured out that was an outlier, so we actually use 65 as the maximum, and then we place a dot out here to indicate that is an outlier. And we're not going to put an asterisk, we're just going to put a dot, and that will indicate that is an outlier. Make sure you label the number line as what the data represents, and and it's on a nicely made number line above it. So the box plot doesn't go on the number line, it goes above the number line. Box plots are sort of magical because they float. Think of them like Harry Potter's candles and such. Okay, so now we're going to look at how we're going to measure the spread. Okay, the most common measure of spread looks at how far each observation is from the mean. This measure is called the standard deviation. Maybe you've heard that term before. It's kind of a common thing for people to talk about in statistics. So what we're going to do is we're going to find the deviation. Consider the following data for the number of pets owned by a group of 9 children. So here we have the data. 1, 3, 4, 4, 4, 5, 7, 8, and 9. We're first going to calculate the mean. So we calculate the mean by, and then we're going to calculate each deviation. And then we're going to, then the deviation will be how much it deviates from the mean. So here's the mean. The mean is 5. So when we add all those up, divide by the number, we get the x bar as 5. This deviation is deviated by -4 because here it is it is a value of 1 minus the mean. This one is deviated by 3, and so we take each data plot and we're going to do that to calculate the deviation. And so then here is a table of those. We take every single data point, list them here, and the average is 5, so we've already calculated that, and then we figure out what each deviation is. We square each deviation. And so we take that -4 and square it. Got it. We then find the average of the squared deviation. So we're going to add up these numbers, 20, 21, all the way to the end, and divide by the number of numbers. And that will get what we call the variance. The variance is a number, so we take 52 divided by, we're going to divide it not by the number, but by the 1 minus the number. We'll talk about why it's 1 minus the number later on in other chapters. And then what we do is we square root that to get the standard deviation. So the standard deviation is 6.5. The square root of 6.5 or 2.55. So what does that mean? What does standard deviation of 2.55 mean? Well, that means that on the average from the median, that the average is the spread from the mean is 2.55. So that would be 1, 2.55 would be there and there. I realize there aren't any data points that are 2.55 from on the dot plot, but that's what the standard deviation is. The standard deviation is signified with S sub x, and it measures the average distance of observations from the mean. It is calculated by finding the average of the squares, as we just did. The average square distance is called the variance. So the variance formula looks like this. So we take, remember the x bar is the average, so we take x1, each data point, subtract the mean, square it, add them all up, divide by 1 n minus 1. And that's the variance. Shorter notation is 1 over n minus 1 times the sigma, that means the sum of all xi minus x bar squared. And then the square root of the variance is the standard deviation. The standard deviation is easy to find once you have the variance. Well, we are not going to be calculating too many of them because we'll let our technology do that for us. But for right now, it's going to ask you some questions that you're going to use that. But now we have two ways of measuring the center and the spread. We can measure the center by the mean and the spread by the standard deviation. We can measure the center by the median and by the interquartile range. So you're not going to mix the two because the standard deviation uses the mean and the interquartile range uses the median. How do you choose which one to use? Well, the median and the IQR are usually better when the mean and the standard deviation for describing skewed. So if because the mean is affected by skewed data, so if we have this big spread and we have these data points way out to the right or the left, then we're going to use the median and the IQR. If we have symmetrical distributions, then we're going to use the mean and the standard deviation instead. As long as they don't have any outliers, then that would mess things up. Numerical summaries do not fully describe the shape of the distribution. Always plot your data. Just a simple dot plot gives you an idea of what the data is doing. We're going to look more into organizing a statistical problem, but here are the steps for doing that. You first want to state the question that you're trying to answer. You're going to plan what you're going to be go about answering the question. What statistical techniques does the problem call for? You're going to make graphs. You're going to carry out the needed calculations necessary, and then you're going to draw your conclusion in the setting of a real-world problem. So state, plan, do, conclude. We'll look at those in a little bit more detail in class, and the book goes through and shows you those steps for solving statistical problems. Well, there you have it. I know there was a lot of math in that. And we're going to, here you learned how to calculate the mean and the median, how to calculate and interpret the spread, how to choose the appropriate measure of spread and center, identify outliers mathematically, make and interpret box plots of quantitative data, and use graphs and numerical summaries to compare distributions of quantitative data. There are the problems assigned. I'll check those next class. If you have any questions, contact me on Schoology or through email. Thank you very much for listening.